So this is our MiniHawk project. It's a VTOL craft, and basically the plans are all free, and I've been into VTOLs for probably about 10 years. Not a lot of success with them, but anyway, you keep persevering. So this VTOL is a bit of a hybrid. We're missing the fins at the moment, and we're missing the ends off the wings. But basically I'm going to be running through today the board, how it's powered up, and basically how to configure it. I've basically laid out the copter so I know what motor and what servos are going to be. So what we've got is we've got motor 1 on the left, motor 2 on the right, we've got the tilt mechanism on the left, number 3, tilt mechanism on the right, number 4, aileron on the left, number 5, and aileron on the right, number 6, and we've got the tail motor, which is number 7. Now, the board itself that I'm using is a KK2 board. A little bit of history about these KK2 boards. The original KK 2.0 came out in about 2011, and they were for quadcopters. And in 2014, this board was upgraded to the 2.1, which is basically what this board is. So you can tell the later revision boards with the red buttons. The earlier ones had black buttons. The 2.0 boards won't work. The 2.1 and the 2.15s will work. This one is unfortunately a faulty one, but it's been replaced. It's fairly new. So what you've got on this side is you've got the aileron, elevator, throttle, rudder and auxiliary, and you've got your outputs. So this is what you would plug your receiver into, and this is what you'd plug your servos and motors into. And this guy here is the ISP rail, which you get one of these ISP units. That plugs into your computer. That plugs into there like so. You power that up and you can flash the firmware on your KK board. Now, the KK board, back in around about 2014, two gentlemen got together and basically put together the manual and the firmware for it. The two fellas are Rand Sinclair and a fella on RCgroups that goes by the name of Happy Sunday from here in Australia, in Sydney. What they did is they took the firmware, made a new version of it and called it Open Aero, and it was for planes. And then later on they updated that again to Open Aero VTOL. Started off at version 1.1 and now they're at 1.6, and that's been like that for quite a while. There's no need to upgrade. So there's a fair bit of documentation on the net about this particular firmware, how to flash it and what it does in the settings. And there's even a graphic user interface for it, so that you can put all your details in a spreadsheet and upload it to the board rather than just manually load it in by hand. But I like to manually load it in by hand. That's how I do it. Now the KK board is basically set up in a fashion. As I said, these are your 8 outputs and these are your inputs. So you've got ground on the outside, positive in the center, and signal on the inside. Now the way the board's configured, the top rail here powers the board and this side. The second set of pins down powers the actual outputs. So if I plug a battery into here, and you'll see this one's defective, it powers the board. So it's powering everything over here as well. If I plug it into the second stage, nothing. I'm only powering this part of the rail. And the reason they do that is they want nice clean power to power the flight controller, and the rest of the power, which is motors and servos, you can power from here, and they don't want the noise from the motors and the servos interfering with the power for the board there, otherwise you could end up with some issues. Now, a lot of ESCs come standard like this guy here, which has got a beck, which has got a 5.5 volt, 5 amp, and that'll produce power. That's what I call a normal ESC. Plug your battery in there, plug your motor in there, plug that into your receiver, and that'll produce a voltage that'll run that as well. So it'll give you 5 volts there. The other type of speed controller is what they call an opto, and there's no BEC on board, which is a battery elimination circuit, and basically that doesn't have that red wire in between, it just has the two, so you've got to get another source of power like a battery. So anyway, that's how it's powered, that's how you program it, and basically once you've done your configuration for here, you're ready to start programming it. Now what the KK2 board has, it has P1, which we'll call hover mode, P2, which is fast forward flight mode, and then there's a center section which is transition. So when you set up your 3-position switch, that's low, medium and high, or vice versa, however you want to set it up. But basically it's hover, transition and fast forward. Now on the KK2 board, all of these pins here are programmable. So you don't have to have them set up in any particular order. All you have to do is know that this one needs power or needs clean power to power the board, and this one here needs power to power up all your motors. A little bit confusing, but really isn't. So once you've determined what you want to run and how you want to run it, it's time then to move on to the spreadsheet that they give you, and on the spreadsheet there's a heap of information. Now these are your outputs, so you've got your output 1 to 8. As I said, my motor 1 here, my motor 1 is this guy, motor 2 is that guy, servo for the tilt is that guy, servo for the other tilt is that guy, the 2 ailerons are there and the tail motor is there, and I'm not using number 8 output. Now let's just go through and we'll see what all this stuff means in here. So if I do that, what we've actually got here is we've got obviously the function, which is the tail rotor. The setting is output 7, which is 1, 2, 3, 4, 5, 6, so it's the second last set of pins there will be that motor, the tail motor. And what we've got here is we've got what sort of device is it. So you can program it to be a motor, an analog servo or digital servo. So in this case it's a motor. P1 is hover, and then P2 is fast forward. So you've got throttle volume. So I want the motor to come on in hover, I don't want it to come on in fast forward flight. There's a couple of different types of curves that you can have. This has got a linear curve. I'll explain a bit more about that later. So do I want aileron volume with this motor in hover or fast forward flight? No. Do I want elevator? Well, I do want elevator in hover, but not in fast forward, because I want the motor off. Then I don't need anything for rudder, and then you come down here to your gyros. Now you've got roll, gyro for hover and fast forward. You've got pitch gyro. Now I've highlighted that in yellow in case I need to turn that on, and that'll mean that I've got kind of auto leveling in hover mode. So we go through, we've got pitch gyro in fast forward, don't need it. Yaw gyro in hover and fast forward, don't need it. Roll, auto level in hover and fast forward, don't need it. Pitch auto level in hover. Now again, I've highlighted that, so if I've got that on, I've got that on. I've got auto stabilization in hover mode. And then you've got pitch dampening, and then you've got all this stuff down the bottom here. Basically, I don't want to go through it, you don't need any of that, but it's all in the manual. So that's how you program number 7 motor. Now if you wanted to do, let's say, an aileron, right, so what we would say here with the aileron, number 5 is our left side aileron, so that would be that would be position number 1, 2, 3, 4, 5 on the board. So that's our left aileron. And then we come down here, it's number 5 and it's analog servo. We don't need throttle. The curve, you have to select one, so we'll just leave it at linear, but it doesn't matter because there's no throttle. You've got aileron in hover, which we don't need, but we need aileron while we're doing fast forward flight. We don't need elevator in hover, but we do need elevator in fast forward flight. So I've made a mistake there, circled those, changed those to 125. And the 125 is the range, minus 125 to plus 125 is for servos. Motors is minus 100 to plus 100. We've got rudder volume in hover and fast forward for the ailerons. And then we've got the rest, which I just explained here within regards to our rolls and pitch. And the gyros and the accelerometers, or the auto level, basically just turn your auto level on or off. So if you want the thing self-stabilizing. So that's basically what you set up for the whole spreadsheet. Then you come to say motor 1 and 2, which are the two fronts. So they're going to be on all the time, they're motors, they're going to be on all the time. Now you can set that value there to the speed. So obviously 100 is 100%. If you set it to 50, your full throttle is going to be 50% of what you want there. So you can adjust the overall speed of the motor based on these numbers here. We want aileron volume on hover, not on fast forward. So if you can see the format here, you start going through filling in what you need for each particular motor and each particular servo, and you record it all on here, print this out, and then of course you go ahead and program it. And basically what this setup means is when I'm in hover mode, the craft will actually automatically tilt, and these motors will act when in hover mode, the motors will react when I give it elevator, and it'll react when I give it a roll. Just the front motors, not the back motor. So I hope that makes kind of sense in regards to what the KK2 board does, how it's powered. Now what we'll do is we'll take a look at the craft and I'll show you what all that means. So we'll plug in the board first to start with, and that gives us power to the board, and this is power to the other rail, which is the motors, and you'll hear them start up. So we're in hover mode at the moment, so you can see that is pitch backwards and forwards, and that is yaw. If I press the button down 1, it'll go to transition mode. If I press the button down again, it'll go to fast forward mode. Back to transition. Back to hover. So these pods here, the guy that designed it for a Dolphin craft in the States, and I just like them better. They stick out a bit further than the original, and they're not as cumbersome to make and set up. And what I did here is I put a folding prop on the back, so that apparently the guy that made the Dolphin was having troubles flying his, and it was because his tail propeller was spinning around and causing some effect that was causing his plane to misbehave. So you can get these folding props for drones, so I'm going to use one of those, and that'll fold back. So if we have a look now and we arm it, I'll show you what happens when you power up, and I'll just walk that through with you. So it's both sticks in and down to the bottom corner inside to power it. So that's now powered. Right, so we give it a little bit of juice, and you can see there, if I power it up, if I go forward with it, the back motor powers up. If I come back, the back motor slows down. If I go that way, it'll want to yaw to the left, or want to yaw to the right, or as I said, pitch forward or pitch back. Now if I go into transition mode, it'll stay there. If I go into fast forward mode, the motors will go down and the back motor will cut out. So there we are flying around now, and our ailerons are working. That's aileron and that's elevator. So if I keep moving that around and I come back into transition mode, you'll see what happens. The back motor comes on and the aileron now slows down, and I go into hover mode. That aileron now stops and the motors now become the ailerons. That's basically how it works. So you've got pitch, you've got yaw, and nothing on the aileron. I'm moving that. Transition mode, a little bit of aileron. Full mode, fast forward mode, all aileron and elevator. And we'll turn the motors off, unplug that, and we'll leave the power onto the board. Now, the amount of transition for your copter is set in the program, so you can actually have how far you want to go. So it's a percentage, 0% and 100%. So if you went 50%, they'd be on a 45-degree angle. So you've got to work out what angle you want this on. I've got it currently set up. Take that battery out of there. About 25%. So I'm still flying, technically flying forward, but causing lift as in hover. And again, this is what you've got to fine tune with your crafts as you get going. You've got to fine tune that to get that optimum angle, whether it's 45. If it's too far forward, obviously the nose is going to drop. If it's too far this way, it's going to want to stay up in the air and not go forward. So you've got to find that optimum angle. You've also got trims in here that you can set up so you can trim these to get them right. You've got an outbound transition time and an inbound transition time, so you can have that going very, very slow if you want to that point and then down to that point, or you can have it going very fast. So you might want to have it going fast to transition and then fast to forward flight, and then have it slow as it's coming back, because you don't want that going, this be doing 30 kilometers an hour, and then all of a sudden it goes into hover mode and starts going all over the place. So there's a whole lot of parameters that you can set the board to make it behave. So there's a whole lot of tuning. So basically that's the MiniHawk. Yeah, so hopefully the props that are hopefully the folding prop will fold back and behave. Hopefully these motors will get to the right transition and fly around, and then hopefully fast forward flight will be able to transition and fly like a normal craft, and then of course be able to slow down, and then of course get the timing for this right, for this to come back to not only the right time but the right angle, so that it slows the craft down so it doesn't want to pitch up or try to crash into the ground. So there's a lot of tuning to do with this particular board. So basically that's about where we're at.